Good afternoon, everyone. It is my pleasure to host this international seminar. My name is Farel, and on behalf of the entire Civil and Environmental Engineering Technology Seminar, or known as SENS, I would like to extend a very warm welcome to all of you. We are pleased to have everyone here and greatly appreciate you for taking time off your busy schedules to attend today's conference. Before we proceed into this session, I invite everyone to invoke the Almighty and pray with your respective beliefs. Let's take a moment of silence to thank God for gathering all of us here this afternoon and appreciate the good health He has graced upon each and every one of us today. Let us pray. Let us. Amen. To formally begin this seminar, I'd like to invite our head of department, Dr. Engineer Alfie Zutiantito, Bachelor of Engineering, Masters of Engineering, to deliver opening remarks for our attendees. Alfie Zutiantito, the floor is yours.
Okay, our honorable speakers, Dr. Martin, Dr. Nugroho, Bu Erni, and Bu Maya, and also Dr. Dave, student from Mudra, and then my beloved students via Zoom. We have 80 students here, and then our faculty member, Bu Anna, and our laboratory assistant. Good afternoon, everybody. Environmental issues are currently the concern of our leaders today, and our big topic research in BINUS is our renewable energy and then sustainable material for the future. And then this event is part of research collaboration between BINUS, Murdoch, and BRIN. I hope today's session can bring all of you listen here, new insight, and maybe someday implement what you can today to build a better future and a better for Indonesia. Enjoy the seminar, enjoy the next today program, and thank you for coming to BINUS. Thank you.
Thank you so much, Dr. Oki, for your kind remarks. Now, among us in this conference, we are privileged to have experts as our speaker for today's seminar. From Murdoch University, Western Australia, we have Dr. Martin Anda, Doctor of Philosophy, Bachelor of Science with Honors, Bachelor of Engineering in Mechanical, and member of the Institution of Engineers Australia. We have Mr. Jack Moore, and Ms. Catherine Abelha, and Ms. Nandin Kaukar. From Indonesia's National Research and Innovation Agency, we have Ms. Francisca Maria Erni Satyarthi Subojo, Master of Science. And from BINUS University, we have Dr. Engineer Dave Namidayan, Senior Professional Engineer. Before we proceed into the main session, a few reminders to ensure an uninterrupted event and to achieve respectable environment. I would appreciate the cooperation from every participant, whether it's here or from Zoom, to silence your devices at all times during the session and to mute your mic at all times during the session for Zoom participants. Any questions concerning the topic can be submitted to either here or through the Zoom chat feature. For BINUSians, to record your attendance, you are required to be present in the Zoom at all times. Finally, participants are required to comply with the rules and regulations applied during this seminar. Now, I will hand over to Dr. Yuriana Wijayanti to take over and lead the main session. The floor is yours.
Thank you, Farel. Welcome make a nice collaboration in this area of geopolymer research, which we'll be talking a little bit in our presentation. So, we'll see you in the Groho.
Yeah, I have to go to PLN, sorry.
Yes, all right.
Yeah, I have to meet the director of PLN.
And PLN is going to be a very important partner in our research. So, I hope the meeting goes well in the Groho. And here I am with our 9 students from Murdoch University, and we have come on New Colombo plan from Australia. And it's a very nice opportunity to be able to come to Indonesia with our students, and normally I do that about once or twice a year, and each time we work with Uriana and Dr. Oki and Dr. Uriani, and it's been a great pleasure over these years to be able to come here and do these projects, and also with BRIN, so we have a good collaboration going. And for this trip I'd like to thank also not only Binners and BRIN for hosting us, but also to Farrell and Andrew and the students for helping to organise many aspects of our trip. So thank you very much for all the support you've given us, and the journey has been interesting so far on Bali and Nusa Lembongan, and here in Jakarta, and Lombok. We had Lombok as well, and each time we're looking at different issues in the environment, like marine conservation, plastic recycling, geopolymer concrete developments, environmental conservation, environmental impacts, and so on. So we look at many different projects around Indonesia, and we try to find projects that we can collaborate with and do the research. But today it's about geopolymer. So let me bring up some slides and give an introduction again to the work that we're doing on the geopolymer research. Is there a laser pointer? Maybe I could use a laser pointer. It doesn't matter if there's not. No laser pointer? No, that's okay. We can get by. Except that is the slide there. So next slide, yeah, sorry. Next slide, that's it. So shortly you'll hear from Jack as well, one of our environmental engineering students. And he was working with Phoebe, who also came last time. She can't be here this time. She's working in the far north and of Western Australia, in the iron ore industry for her summer vacation break. Work we've been doing. So the common thing about Australia and Indonesia is that these are 2 countries that are rich in energy resources, and they both have very abundant amounts of coal. Okay, so we're both very big coal exporters and very big coal users, and so as a result we have, because we use so much coal, we have highly carbonised economies. So this is a challenge, how we do this transition out of a carbon economy. And we have issues of remote energy access. Like Indonesia has 17,000 islands, and many of them are remote with villages, like in eastern Indonesia. Many poor remote villages that need access to energy under the Sustainable Development Goals. And then also in Australia, we have very many remote desert communities that also have challenging energy access issues. And then we'll also have future issues in energy demand. So we've got lots in common between Australia and Indonesia, and that's why we can do some good research together. Okay. Oh, look, let me just say, this is a big coal mine. This is the Blue Waters Power Station at Collie I'll be talking about, and then we just need very big transmission lines to move the electricity around the country. Okay. And this is the power station that we went on that last trip. This is the Suralaya Power Station, just outside of Jakarta. It's a very big one. It's 10 times as big as all of the power stations in Collie in Western Australia that give 50% of Perth's electricity where we all come from. So this is a very, very big power station using many shiploads of coal, which I think is probably coming from South Sumatra or Kalimantan. And this is just one, and we owned by Indonesian Power. There's the power station background. And the interesting thing about the Suralaya Power Station is that the fly ash is, well, maybe I should say, the electricity system in Indonesia, if you don't know, is run by PLN. And then the generators, like the coal power station, are run by a section called Indonesia Power. And then after the coal is burnt and the fly ash is taken away, the fly ash is run by a company called EPN. And EPN is a very interesting company for us to work with because 90% of the fly ash already goes to concrete companies and only 10% goes to landfill. And so EPN is experimenting with some of the 10% not already going to landfill, and the 10% that is normally buried from this power station is equal to the total amount of all of the fly ash produced in Collie where our coal-fired power stations are. So you can see here they've been making some bricks and lots of things out of fly ash, and that's the type of research that we want to do towards geopolymer, because they're not making geopolymer here yet in Suralaya. They're only making concrete with fly ash as a supplementary cementitious material. So, you know, it's a great opportunity for us to do this research with PLN and Indonesia Power and EPN. Okay, in Collie, we're now slowly starting to demolish our coal-fired power stations. We've been slowly turning them off for the last 10 years, and we'll be turning them all off in the next 10 years. And but the coal mining will probably continue for another 20 years because there's other industry. Oh, how much time have I got here, Rihanna? Is that my... How?
7 minutes.
How much? 5 more minutes. Okay, I'll go quickly. Okay, let's go to the next slide. That was it. So this is just a schedule. We're going to shut down our coal-fired power stations. Okay, and anyway, I'm just comparing the size of the different power stations in Western Australia and Indonesia, and how is concrete made. So I think some people were here last time, so maybe I won't dwell on this. But look, the main thing is that, and I probably don't need to be telling civil engineers this, do I? How concrete is made. But the main difference is, instead of using Portland cement, we're taking fly ash. Which slide is this? No, this is not the right slide. Sometimes fly ash is used as a supplementary cementitious material along with the grey cement just to reduce the amount. And then we end up with the concrete. But we want to stop this because it's very high carbon emissions and find alternative materials. Okay, next one. So what we're doing in our research is we take the fly ash and we put it into one of the tests in the chemistry department using an XRD machine, X-ray diffraction. And what we're doing with hands is we're analysing the fly ash for the amount of aluminosilicate in there that is amorphous, the proportion that's amorphous versus crystalline. Because if we can find out the amount that is amorphous, we know how much chemicals to use. This is the reactive part. That's what we're looking for by doing the XRD machine testing. And then what we've found now is the best way to go through and develop the different mix designs is in one laboratory we just take small 25mm vials and we just use we develop geopolymer mixes in small test batches, and we can just crush them quite easily to test them. And then once we think we have a good mix design from these small vials, we'll then go down into what's probably our field laboratory, and we'll be pouring much larger 1 litre cylinder molds. And and other such moulds as well, and getting the experience using the preferred mix design of the geopolymer. Okay, next one. But this is just Collie. This is Collie in Western Australia. You can see up here, bottom left corner, if I had a pointer or a stick or something, I could probably, but anyway, that's just where we're working in Western Australia, okay? That's where our power stations are. And this is the supply chain that we've been analysing. If we're going to build a geopolymer concrete industry in this small country town, 5 minutes, then we need to import materials from these surrounding areas. And I guess this is what we'd like to do in Indonesia too, is understand what the supply chains would be if we're going to build a geopolymer industry here, where we would need to source all the materials from. This is just an aerial photograph of one of our power stations in Collie. It's the Muji power stations. And so even though coal will be turned off in most places in Australia in 2030, many of the power stations have the big containment dams, so we can still extract the fly ash from there. And are there containment dams on the power stations in Indonesia? Do you use these ash storage dams in Indonesia? So now the coal will probably keep burning in Indonesia until 2040 or 2045, 2050. So there's a lot of fly ash for many, many, many years to come. So it won't be running out. But in Australia, we'll stop burning coal probably 2030, 2035. These ash containment dams can still be used because they'll hold large volumes of the fly ash. Now here's where we make the geopolymer. Okay, so we've got the fly ash, we've got the priming chemicals, and we've got the cement, and then we can produce a cement binder. And this is Ramon, he's one of our expert mix designers. And then we mix it with sand and aggregates. We can make our own sand and aggregates too. And then we produce the polycrete, as we call it, the geopolymer. And well, this is just a process flow diagram of what I just explained, basically. So these are the. What I'm saying here as well is that even though our priming chemicals are mainly sodium silicate and sodium hydroxide, and we can normally buy those from the chemical companies, we can actually make those ourselves. We haven't started doing that yet. But a really interesting project is we can make the sodium silicate from recycled glass, but even more interesting for Indonesia is you can make the sodium silicate from rice husk ash. So one of our students, Phoebe, who has started work on that, and there'll be a nice project to do with Binus University in Britain and see what sort of batches we can develop together in the laboratory. So there's many exciting things to do all the way along this process flowchart. There's many parts of research that are still necessary. Okay. And then these are the benefits we'll get from geopolymer concrete, is it reduces emissions, zero waste, and we create new industry, new jobs, so we get those community benefits. And the mix designing is quite a complex art, and I know Dave is going to give a presentation shortly on his literature review findings, so I'm very interested to see what his recent findings are from the literature, what he's uncovering in the new chemistry of geopolymer concrete, that we can design a lot of complex tools. And in fact, Ramon has developed quite an advanced online tool for doing the mixed design work. Yep. You can see it here, just the readout display there. And we just do a whole range of testing. I mean, the main guiding test we do is compressive strength, but there's other various tests we can do, and I think they're consistent with what you're all doing in your civil engineering laboratories anyway. So from that point of view, there's not a lot of difference, because now we're at the end point of concrete. But one of the things we also are doing in something like geopolymer concrete made from waste materials is what's called leaf testing. So long-term leaching, for example, in a marine environment or an aquatic environment, is there any dangerous chemicals that might be coming out of it? From the research I've seen, we don't think so, but normally the regulators don't want you to do that research anyway. Okay. And many sustainability benefits here. You can see the greenhouse gas production going down and then the recycled material going up. So, you know, there's great benefits in using this material. Okay. We're doing site analysis on different locations where we can build a new factory for the geopolymer. Okay. And this is an example of a design of how you would design and build a geopolymer factory. Again, one of our students, Jared, has developed this particular design, but there's others as well. Okay. And then another master's student has developed the design for a chemical handling plant, and we've ordered that now, and that was meant to be delivered probably today to our laboratory, but it's going to be delayed until next month. And then we're hoping to build a much larger one in Collingwood so we can start doing much larger pours of this geopolymer concrete. Okay? And this is our Indonesia team so far. But we have to add some people like Ernie. We need to put Ernie there in the picture. If you've got a photo, you can send me Ernie. And Dave, we have to add Dave as well. We should have Dave up here on the team. And some of your research students, Uriana should be alongside you here, so we need to build up, and the BRIN research team as well, we need to add as well. Okay, keep going. Okay, now just quickly, there's 3 key areas where we think the research could be useful in Indonesia, but this is what we need to discuss together. Number 1, we need to build coastal armour, and Dr. Oki is a world expert on marine structures, so it's going to be really great to work with Dr. Oki on this. Number 2, option 2. Some videos you can watch about this, but we haven't got time to watch that now. We go to number 2. So then blocks for large scale construction blocks, so we can, there's an energy storage device, which I want to tell you about, but that's another story for another day. That's what we're focusing on in Australia. It's an alternative to lithium-ion batteries. It's a gravity energy storage system, and these geopolymer blocks made from waste is going to be a great opportunity for this. Number 3, again some videos, but we'll leave that to another day. And high profit wall panels. So wall panels in buildings, very profitable. To make concrete wall panels, this is the most profitable opportunity to build low carbon buildings. So that is going to be a nice industry. Next one. More videos, but we'll watch that another day. And the research questions, can we use mining tailings? Can we develop a heavyweight mix for the energy storage device? And can we develop a lightweight mix for the wall panels? Okay, next one. And then there's some details on the research plan which we can discuss over a cup of coffee later. And then the final one. This is what we had a look at last time, okay? So that's just some pictures from our last visit, okay? And when we went to Brennan Business. And then the big opportunity, that last slide there. If we go to the next slide. And there's the big opportunity. So the Australian government and Indonesia are working on a partnership together. So our new Prime Minister came and met with President Jokowi last June. And so what I want to work on is this $200 million climate fund. And together with our university partners and industry partners, we might be able to have access to this funding and build a geopolymer industry in Indonesia. All right, thank you. Any questions?
Thank you so much, Martin. I'm sorry for the arrangement. So after all the presenters present, now then we can open the session for question and answer. Can you show the students online? So I want to check, is everybody online is here? So for the students, when you check, we have around 70 students online now in Zoom. So they will write their question in the chat box. Later on, I will read the question and for the presenters. Yeah, okay. Okay. So for the next presenter, I would like to invite Ibu Erni. So I met her in September. So now she's doing a PhD in ITB, same campus as Dr. Nugroho. Yeah. So she's a researcher in sustainable and life cycle analysis research center. Okay, please, Ibu Erni, the time is yours. So students, please write your questions. You can chat directly to me or during the question and answer, you can turn your microphone on. So we have 80 students online. So because now they have so many exams, so they're joining online. Ibu Erni, time is yours.
Thank you, Ibu Ana. Hello. Good morning, everyone. It's nice. It's a very great opportunity for me to present some of my research here. When Ms. Anna said that I must present something in this event, I try to relate my research actually is in PVC sustainability in PVC, increasing sustainability PVC product by increasing its degradability, also in processing like pyrolysis process, and also from the recycling properties. But in this moment, I will try to enlighten a little part of the research is to see the potential research of study PVC product, especially as a construction material. Okay. As we know, PVC is sorry. Okay. Yeah. As you know, PVC is one of a thermoplastic material. If you know polyethylene, polypropylene, and the second of the third commodity consumed globally in the world, or in Indonesia, is PVC, polyvinyl chloride. And the challenge of the application of PVC is very challenging, because of some of properties with chlorine. There is so many issues about the safety of this material. But as we see here, the consumption is always increased, expecting increase until even until 2030. The application of PVC is very large, because its polarity, because PVC is very polar. It can be modified, but with many of additives. So we can have a very large scale of PVC, from the flexible one to the rigid one. From flexible, we can find wrapping plastic. It's made from PVC, and flooring. It's also from PVC. And also the rigid one, you can find roofing, window framing, and also piping. You know, the most application PVC is in construction and building material. Okay, next.
working on that.
and also from salt, yeah, and we polymerize the vinyl chloride monomer by addition polymerization. And when after we have the polyvinyl chloride resin, we do the compounding. Compounding, we put some additive depending on its application, and it's become a PVC compound. And after that, there's another process, and we have a PVC product depends on its application. What is interesting is in this study is today, this morning, we visit David Hope, right? And they produce one additive called Osium. Osium is a pro-degradant additive. And actually, Linhope have already commercialized PE Osium, PP Osium, PS Polystyrene Osium, but not yet PVC Osium. So PVC Osium is not commercialized yet. That's why I try to make some research in
PVC Osium.
Yeah.
Yeah. There is some properties of PVC. It's not
easy to compound the Osium with PVC. After 3 months of research with Linhope, finally we get the good parameter process to mix the Osium and the PVC. And after that, actually now I try to make blister packaging for PVC. You know, the blister packaging is when you have the tablet, yeah, the packaging, the transparent one is made from PVC. And there's a pharmacian company, Japanese one. They ask to breed to make PVC also in order to upgrade their sustainability report. So they have PVC also biodegradable material. So the challenge is to make a good formulation first of all, and to find the good before we go to really to the cradle to grave. But we have a preliminary research before the real getting the primary data from the industry. We have already some bulk data from the industry, and we try to analyze its sustainability by making a scale of its impact. Okay, next. This is the unit process in gate battery that I have to do the life cycle inventory. Yeah, the data and calculation is made for a system process. Next. This is some research, some existing research. Yeah, we measure already the energy consumption, air emission water, and waste treatment. Yeah. We collect the data for upstream and downstream industry. Yeah, and we also use some database, yeah, to complete the missing data from the primary data, because it's not easy to get. It's not easy to get the primary data from industry. So we must really have a good strategy and good cooperation to have a primary data. Okay, next. I think it's already. Yeah. This is some research in Indonesian PVC industry manufacturing. The first table is for energy consumption. We can do the comparison between manufacture of PVC and also comparing to other polymer. Oh yeah, in Indonesia there is four big producer PVC resin, and we only get the bulk data or the system process data, and we compare it with the data of reference in Japan. As you see here, the result is quite same, yeah. And also we try to get some sampling for six product kind of product of PVC, which is pipe, cable, imitation leather, profile, film, and clothing. And this the comparison. We see that the total energy consumption for production of cable is the biggest, and then film is also quite big. So there's some opportunity to make an improvement in their process. Next. This is the result of 6 products. Yeah. We measure the CO2 emission, the land use, the water consumption, and also we put the 3R, recycle, reuse, recovery. We only compare between the 6. We put the 1 star for least frequent, 2nd for frequent, and 3 star for most frequent. Yeah. But as this is only the preliminary study, so I try to make the scale of the 6 sample of PVC product. Next. Okay, this is the result. Yeah, you can compare for 6 product. Next, air water emission also. Next, I conclude with the conclusion. The energy consumption of PVC resin producer in Indonesia is within the national standard and also similar to PVC resin producer in Japan for both electricity and steam consumption. According to the national regulation, the PVC resin producer in Indonesia also have an acceptable amount of SO2 and NOx concentration in their air emission. The amount of Indonesian PVC resin producer water emission criteria is also within the allowable limit based on the national regulation. So based on the result of the LCS study, the type of PVC products sorted from the most environmentally friendly are PVC pipe, wire, profile, roof, imitation leather, and film. And it should be noted that the data obtained are not all direct survey data, but there is still some literature data due to the availability, accuracy, and time limit. So after this preliminary data, I will complete. I try to complete the life cycle inventory. So we hope that we will have a better and accurate analysis. Okay, thank you, and give the time to moderator, to Anna.
So much, Ibu Erni. So we move on to the next presenter. I would like to invite Dr. Dev Hamidaan from Professional Engineering Program, University.
Yes, check. Okay, good afternoon, ladies and gentlemen. Thank you very much, Dr. Martin and Prof. Martin, for coming from Budok University to come to Venus University, and as well as his students. And today, I would like to present maybe not about material engineering or civil or environmental engineering topics, but this is more about like a literature study, review of literatures, as well as a little bit of data mining analysis, something like that, in order to check think it is said as OVADIS. Yeah. So geopolymer research, where will we gonna go? OVADIS. Next. So I will give a brief introduction about the OPC, ordinary Portland cement, from the perspective of simple stoichiometry reaction, where the Portland cement content of calcium silicate originated from CaO, and it is originated by burning calcium carbonate. So from the stoichiometric perspective, 100 kilograms of calcium carbonate will be converted into 56 kilograms of CaO, calcium oxide, and also carbon dioxide emission 44 kilograms. So all of it, it's about 50-50 kilograms, 50-50% mass of the cement, of the calcium carbonate converted into carbon dioxide. And to put it quite extremely, all of the cements we need to build all those buildings, apartments, skyscrapers. All the masses are equal. There are equal mass of those buildings in the atmosphere. Yeah. So, and I checked that the cement industry contributes 8% to the global warming. So, what would be the solution for this? And as we know, since we are discussing about geopolymer, I will direct the solution to geopolymer next. Yeah. So this is the geopolymer technology. I take this slide mostly from Prof. Zhang from Arizona, University of Arizona, where similar to what Prof. Martins presented about how to make concrete. So for this one, we want to make concrete based on geopolymer cement, where aluminosilicate source mixed with water, and I also activated with alkaline, sodium hydroxide, NaOH. With this kind of reaction, will be converted into geopolymer paste, and this is the details for how the molecular form in details for the dehydrosilation of polysilane siloxane into the 3D framework, and it can make this kind of structure, satellite framework of sodium PS, polysilane. It will make a molecular cage, and as we know that geopolymer and also Portland cement is quite comparable. Okay? But we want to explore more on different aluminosilicates or different processes, etc. Especially when Martin said about Indonesia PLN will still burn coal until 2050. Yeah, so it will quite an opportunity for us for next 25 years. Yeah. Okay, next. So, okay, so yeah, as I talked about aluminosilicate sources, there will be fly ash from coal-fired power plants. Also, rice husk as Chigi a few months ago came and discussed about rice husk for geopolymer. And also, we need also to check about high potential for research from this kind of research in these aluminosilicate sources. And what would be the research direction? And this research direction that is what I'm gonna try to present today. Next. So geopolymer research direction. What to do? What we need to to do what we need to perform in order to have a research direction. So I go to Scopus. Scopus is like a Google Scholar, Google for scholarly academic papers, and this is a database where I can also download metadata for title, how many citation, who are the authors, and etc. And I can perform some numerical analysis, and I get that okay, this is the profile of the publication from 1980s, 1984 to be exact, to 2022, and this is as of today. There are 10,000 titles and metadata, and the profile is going up exponentially. So can we write this? This is similar analog to like a wave. I believe some of you have surfing in Bali. Maybe. Yeah, can we write this wave? Sure. After we perform some proper mapping. Mapping by what? By I did some small paper about mapping of community service about waste management in Indonesia. I performed literally mapping here and there the points, but also I also made the bibliometric analysis and also systematic literature review next, and and there are some titles, two papers I published this year about bibliometric analysis about waste food energy nexus by using black soldier fly larvae, and also waste management in Indonesia in the COVID-19 pandemic area. Initially, I also want to make this geopolymer as the third one, but unfortunately, I got COVID last month for 3 weeks. So there's a delay. I'm sorry, Martin for that. And next, so maybe like a qualitative research about the word cloud of what are the dominating keywords from that to 10,000 titles, 10,000 metadata. Those articles have keywords, and that keywords are I put into a word processor, and we get it. Still, there are some pop up below geopolymer, but strength, compressive, etc. Are still dominating, and there are some. I also map the publication outlet, which potential journals frequently discuss about geopolymers. So at the top, first is Construction and Building Materials from Elsevier, where it publishes 1,000 papers plus. IOP, that's the conference series. The third is Materials from MDPI, Ceramics and International and Cleaner Production, 250 papers each from Elsevier and etc. Next. This is who's who published highly cited papers, and most of them are from Dachsen, Van Deventer, the pioneer in geopolymer from Melbourne. So I believe, I hope we will our collaboration will put our name on the table in following years. Dachsen, Van Deventer published in 2007. It got cited almost 3,000, 2,700 in journals of research, etc. Most of them are literature review papers, and maybe we can also make some literature review papers as well. But in parallel, we also need to perform more on we need to balance between dry experiment and also wet experiment, right? do some XRD, mix the geopolymers, mix the aluminum silicates in the lab, etc. Okay, so this is like brief description on the condition of the research in this topic. Next. So I performed this on the next. Yeah. This is a first viewer visuality of similarity, visualization of similarity software, where all those keywords are dumped into the software, and it will give this graph where the diameter of the balls of the circles corresponds to the frequency of how frequent the keyword pop up. Yeah. So there are 10,000 publications. There are 1,000 publications after I performed some threshold limitation, and I removed some very general keywords like geopolymers, compressive strengths, etc. But at this point, there are still some 900 keywords. It's too much. I need to chop down the mapping, and therefore I try to find the niche that is suitable for Indonesia case, where as I discussed with Dr. Oki, he said that acid resistant application of geopolymer is will be interesting, and I checked the data. It's not too much at this moment. There are only less than 200 papers, but the growth is also quite following the exponential trend. And geopolymer for acid resistant application will be exciting for Indonesia, because Indonesia has ports in seas where seas are very corrosive, and also Indonesia has long coastline, and since Indonesia is archipelago and maritime country, there will be some ports, especially new ports to be constructed, especially for the IKF, the new Indonesia capital. This kind of application will be in demand. Yeah, next. Yeah, so this is similar with the previous slide, but this is for after I focus on geopolymer and acid resistance. Yeah, so yes, still construction and building materials from Elsevier has almost 50 papers. It will be potential journal for our research. Next. Yeah, this is the top 15 papers about geopolymer reviews. Mostly are reviews. Next. And next. Yeah, so this software, when I perform some cleaning of the data, processing of the Excel files, I also can get this kind of mapping of keywords, but when I click the bubble for acid resistance, it will display the connection between acid resistance and other keywords that are connected or whatnot. Yeah. And so there will be a research gap of those over here. It's about maybe, it is not really quite connected to kaolin, phosphoric acid, electrical conductivity, incineration, also carbon. Yeah, so it will be research gap to pursue in the future. Yeah. Okay, next. So this is the small mapping of research direction from this Scopus database. After I perform keyword analysis, publication analysis, etc., there are some research directions to go in the future about acid-resistant geopolymer and also exploration of different kind of aluminosilicate sources, as well as optimization and also other things that will come in the future for continuous improvement, other exploration, etc. Thank you very much for the time and opportunity to listen today, and I will return to the time to the floor to thank you very much.
Thank you very much, Dr. Deep. Very nice presentation. So now I would like to invite the speakers from Murak University students. So I would like to invite Catherine and Mary to present a topic about the diploma grant. So you will present together. Yeah. You may start.
Selamat sore. Nama saya Madeline and this is Catherine, and we're students from the University in Perth. We're here thanks to the Australian government's funding through the New Colombo Plan. So we're just going to tell you a little bit about what we've done in Indonesia over the last couple of weeks, and about some environmental problems that we've noticed are similar between Australia and Indonesia. Next slide. So I'm an environmental science student. I'm from Perth, and environmental science is a very multidisciplinary field. So we study ecology, so how plants and animals interact in their environment and with each other. We also learn about the atmosphere, weather systems, geology, and landscape formation. We learn a lot about environmental problems, such as climate change, mostly due to human activity. But we also learn about how to repair the environment once it's been damaged. Next slide. Hi everyone, I'm Catherine. I'm also a recipient of the New Colombo Plan Scholarship. And so it's an honor to be able to speak to you all today. I'm really excited to be here. So I'm studying at Murdoch University at the moment. I'm doing my undergraduate at the moment. I just finished my second year. I'm majoring in environmental science and management, as well as international aid and development, which just makes it super exciting for me to be here in different countries so I can see the international responses to environmental change. Some of my interests is learning about international responses, problems arising from climate change. It's something hopefully where I want to go in the future. And I'm interested in building a global community to tackle these problems, as well as looking at interactions between the environment and humans. Next slide. And that's just me. We had an ecology field trip and I went down to Albany for a week to do some field work, which is super exciting. And on the left is just Banksia plant, which is one of Australia's natives. So today we're here because of the New Colombo Plan, or NCP for short. It's been an amazing opportunity so far. I think it's really good to help promote the Indo-Pacific relations between Australia and Pacific countries such as Indonesia. And currently they have connections in over 40 countries, which is super exciting. So there's a range of programs through the NCP scholarship. So the ones that these will on today, there's only 2.5 weeks. We arrived on the 7th of December. We've been travelling around Indonesia to lots of different places, which has been awesome. But there's a range of opportunities for people. Some of them are semester long, and these opportunities can extend to be a bit longer if people get internships or other roles. So I'm going to tell you a little bit about WA. So Western Australia fills the whole western third of the country, so it's pretty big. And because it's so big, there's quite a lot of, there's 3 main climatic zones. So in the north, it's subtropical, So the southwest is a biodiversity hotspot, and parts of Indonesia are as well. And to qualify as a biodiversity hotspot, the area needs to have more than 1,500 endemic plant species, so plants that are found nowhere else in the world. And it also needs to be threatened by human habitation. So the southwest of WA has over 13,000 native plant species. About 4,000 of those are endemic, and unfortunately around 70% of our native forest has been cleared, mostly for housing and agriculture. And that's a picture that I took on the Murdoch University campus. It's a Banksia menziesii. They're one of our endemic plant species, and they're very common all around Perth. Next slide. Yep, so I just wanted to show you some of the plants that we have. So on the left there is a calitrix, and calitrix literally means star, because the flower is shaped like a star. And I also found it kind of interesting because there's a star flower that I saw in Bali last week, so I took that photo on our trip. It's actually native to the West Indies, but apparently Balinese people use it as a cure for some eye conditions, which is kind of interesting. Next slide. The top photo is probably one of my favourite plants that we have in WA, so it's called Drosera or sundew, and they're carnivorous, so their leaves, they have this sticky sap that smells really sweet to insects, so they attract the insects to their leaves. The leaves are these like spike things on the vine there, and digest insects. And the next one is Phasinotis, also known as a fringe lily, because you can see it literally has this like fringe around the petals. And those flowers, they only flower for one day. So if you see one of those out in the bush, there's a good chance you're the only one who will ever get to see that flower. Next slide. So today we've heard a lot about some of the environmental problems in Indonesia. So in return, I thought I would share with you some of the environmental problems we're currently facing in WA. So one of the main problems that has led to various other environmental problems in WA is urban sprawl. So this is due to we've got a north-south linear morphology with the development of Perth. So it's super spread out on the coast due to the high value of coastal living that's existed in Perth, but that means everything's like really far away from each other, which has put some ecological communities in danger because development spreading into their environments, and lots of areas have been cleared for housing. It also makes it a little bit harder to get from like one side to the other. For me anyway, so I've been training for quite some time. There's also many endangered species throughout WA, as I was saying earlier, it's a biodiversity hotspot, but many of our animals are unfortunately endangered. Some of these animals include black cockatoos or small marsupials such as a bilby or a nutbat or a western ring-tailed possum. And some of our marine turtles are also endangered, such as the leatherback and the loggerhead. Outside of WA, I'm sure you all know this animal, the koala, is also unfortunately endangered. Even though it is one of Australia's natural emblems, it is still endangered. So Australia, especially WA, is experiencing a lot of the negative effects from climate change. So we're experiencing quite a warming climate, so feels like each summer we've had record high temperatures, which has been a little bit unfortunate to experience. There's also been increased drying, which has led to a really increased bushfire risk. So in 2020 we had bushfires across what felt like all of Australia, which also led to a lot of environmental problems. And Australia also has a high dependence on groundwater, which is causing a few environmental problems for us as well. And next slide. This is just a koala, and then here on the left over here, you can see our fire rate scale. So the second is high, so you can tell it's normally pretty, you normally have quite a high fire risk, so it will normally sit in the blue yellow. Unfortunately in that photo it's in the catastrophic region, so probably the fire is happening nearby to that sign. Next slide. Yeah, you can press the button multiple times if you like, there'll be like multiple photos coming up throughout SOC. So while we've been in Indonesia, we've seen a large variety of things, which has been super exciting. So first place we went to was the Turtle Conservation and Education Centre. So here they rehabilitated some injured turtles, which was really good because some of the turtle eggs were being sold in the black market, so they're also rescuing those. And just helping protect marine life, which we love to see, and now all the turtles they rescued would eventually get returned to their habitat when they were healed and recovered. We also went to Kopanek, which is a non-governmental organisation Consortium, and they were located in Brisbane. They're doing a variety of community-driven projects with the community. It's also from the Conservation Centre. So one of their current projects is in Nusa Penida, and they're providing training to the community members because there's been desalination plants for water to ensure that all the local communities are able to have access to fresh water more easily. So they've been providing training to community members on how to run these desalination plants, as well as about how to run business and to maintain the equipment to provide clean drinking water without having to constantly boil the rainwater. So they've been providing lots of water, which has been really good. You can just I think it's my final photo. In this photo, if you just go back, that's okay. Yeah. In this photo, you can just see Martin demonstrating how the desalination works. Then also, the wastewater project is when local community members brought in rubbish and exchanged it for water, which promotes like cleaning up the environment and like the economy and stuff. Covenant also has a lot of partner organisations which they do this wastewater project with. This helps reduce pollution as well. We've also had the honour of being able to attend 2 DFAT seminars and conferences while we've been here, which is at the end of one of them is when Martin presented his thing, so it's been really awesome to be able to talk to different people and learn their insights and stuff. We've heard from a large variety of professionals about like plastic exchange businesses. We've also spoken to people from the Coral Triangle Centre, and today, for example, we went to Green Hope to learn about the biodegradable plastics, which is really cool to see, and I'm excited to see where they go from that. And of course, we've seen some fantastic environments because we have been doing some touristy things as well. So I've seen some awesome things while I've been travelling in Indonesia.
So Australia and Indonesia, I've noticed during our trip, have a couple of environmental problems in common. One of the big ones being groundwater, particularly here in Jakarta. Perth also used to rely very heavily on groundwater, which is kind of a problem because groundwater gets replenished by rainfall, and since the climate is drying, the groundwater wasn't being replenished fast enough to keep up with our growing population. This is especially an issue because groundwater is usually used in Perth to irrigate lawns because we don't get a lot of rain over the summer. So to kind of solve that, since 2006 we've been using desalination as an alternative to groundwater, so we pump water from the ocean, desalinate it, and use that as drinking water supplies. So you can see this kind of shows the proportion of our water that's for groundwater and for desalination, as well as dam storage. Also, in recent years, we've started using treated wastewater to replenish the groundwater. So wastewater, they were treated to so it's beyond drinking level standards, and then put it back into the groundwater. It will stay down there for a couple of years, and then it will feed back into the system. Jakarta is also facing a similar problem of groundwater overuse. So due to over-extraction, it's actually causing the city to sink several centimetres every year. Perth is also sinking up because our population is much smaller and we rely more on desalination now. It's not sinking as fast, it's only sinking about a couple of millimetres a year. But in Jakarta, the causes for using groundwater are a bit different. It's because a lot of people dig groundwater in their own homes because they don't have another source of clean drinking water. And apparently desalination isn't used quite as much here as it is in Australia, other than small projects like the one Catherine talked about, and also wealthier areas that can afford the technology. But that's just a photo of the desalination plant that we visited on Vessel and Longin in a high school because their well went salty after rising sea levels. And that's a photo of, that's in Lombok. We went to a waterfall. I don't know where it was, our driver just drove us to a random waterfall. But we asked the guide afterwards whether there was any old growth forest left in that area, and he said no, it's all been cut down. So that's another similarity between Australia and Indonesia is that we don't have a lot of old growth forest left because it's being cleared for human habitation. This is having quite a bad effect on the biodiversity.
So, just before I came on the 4th of December, I had the opportunity to volunteer at a Future Homes Expo. So this was the 4th of December. So I just thought I'll talk a little bit about what I learned when I was volunteering there, because it was all about sustainable infrastructure in Australia, which relates to geopolymers and doing sustainable building. So we learned about a large variety of different building forms and sustainable building options in Australia. And there was a large variety of products. Because there was like a heap of stores now all advertising something different, which was really cool to see. So there was, some of the examples was hemp wood or replacement like hemp concrete blocks for building. Hemp provides a lot of benefits to building, especially in Australia, because it's fire resistant and also repels some of the insects and allows better distribution of temperature throughout the house, because it can get very hot in Australia, just like in Indonesia. And they also had wood that could be sustainably harvested, which is all really awesome to see, but a lot of these sustainable options were quite expensive. So if we want to have large systematic change to occur, sustainable living needs to be able to be affordable and accessible for everyone, including those who don't have much money. Next slide. Thank you so much for listening today. It's been an honour to be able to present to you guys. I'm looking forward to questions as well.
Thank you very much, Marilyn and Catherine. Smooth presentation. So we come to the last speakers. I would like to invite Jack Moore to present, last but not least, your research progress on geopolymer research. Thank you.
Good afternoon, everyone. I'm Jack Moore, and I'd like to present to you. Some of the results of this project I've been working on for most of the last year, and some of the methods that I've used, and how you can speed up your development of geopolymers and if you're interested. Next slide, please. All right. So first off, a bit of background, which has already been touched on. So the production of concrete is responsible for 25 and 8% of the world's carbon dioxide emissions. It's 5% of 5%. The 5% figure is just if you count the chemical emissions from turning limestone, acid carbonate, into calcium oxide and carbon dioxide. The 8% is if you include the fossil fuel. If you include the emissions from the fossil fuels used to heat it, so that it does decompose. Next slide, please. Hi. So one alternative to this is geopolymer concrete, which is made by combining an aluminosilicate source material, one that's reactive, preferably, with an alkaline solution and soluble silicates. So it's estimated that using this can reduce the carbon emissions from concrete by up to, by between 60 and 80%, because you don't need to calcine limestone. So most of the carbon emissions during the process are just electricity. So there's a bit of a diagram here with a bit of theoretical background, but we won't really cover that. It's it gets very complicated. So next slide, please. The system that is most common in the literature, and one that I've been testing, is just a mixture of slide, he has seen under a microscope sodium hydroxide and sodium silicate, also known as water glass. So all you really have to do is mix these in the right proportions, and you get a concrete article, and you get an alternative to concrete. But the problem is figuring out exactly which proportions to use. And there have been a few methods proposed to do this, like the one Dr. Martin mentioned, using XRD or X-ray diffraction. But the problem is that requires a very, very expensive machine. And actually, when I was here a few months ago, and I also had the honor of presenting here, we also did a grid, which as I said, is one of the only places that has an X-ray diffraction machine available, and it's kind of under high demand. Unfortunately, because this system is so complicated, it's not really possible to chemically model it. So we need to resort to experimentation. I'll present through that in a moment. Next slide, please. That's how you make it. All right. So we can represent a mixture visually on a ternary form like this. So each corner is 100% that material. So 5% silicate, so this is just an example that shows up easier on the screen. In reality, you usually have 4 components because you also add water, So the first trick that we can use to speed up figuring out which components work is knowing the boundary. So next slide, please. So we know that you need a certain amount of sodium silicate, but not too much. I found that adding more than 30% actually just makes the product swell in there by absorbing water and then cracks. So it's not more suitable for construction. But at the same time, you do still need a certain amount to give improved strength. There's a similar situation with sodium hydroxide and also with lime. If you add too little, it'll just be wet and won't have a cure, so you'll still have wet concrete. If you add too much, it'll just be a powder with no strength. So this pink triangle in the middle here, that is the range of mixtures that will give that we think will give pretty good results. They might not all be very strong, and some might take too long to harden, or might harden too quickly, but pretty much all of them will work in some way. So the challenge then goes from figuring out which mixtures in here work, figuring out which mixtures in here work. Much easier. Okay, next slide please. So now we need to figure out to figure out which mixtures in those work, we do some experiments. So the number of experiments that you do depends on how much time and resources you have. Obviously, you would like to do more, but each one takes time, it takes some money for the chemicals. So there is actually a statistically best way to do it, and that is to take a number of design points that are evenly spaced. So in this triangle here, they're more spaced as far apart from each other as possible. That means that you get the maximum amount of information from each one. So depending on how much time you have, you take the vertices. If you're time, then also the edge centroids and then face centroids, and then you go and then the overall centroid here. Yes, yeah. So this is the best balance. This is the best balance that you can get between accuracy and thoroughness. So in my experiments, I mixed the chemicals, cured them in the oven at 80 degrees Celsius or 18 hours, and then let them cure for a week before testing, and then before testing their properties. Next slide, please. And so here are other design points that I did. I use the components fly ash, silicon oxide, which you get in the sodium silicate, sodium oxide, which is in both the sodium silicate and the sodium hydroxide, and added water. Next slide, please. And the last step is after you've done your experiment, is a mathematical function to your data. So this is called a Chef polynomial. What's special about it is that each variable, each x here, represents a proportion of a component, and then each one has a coefficient assigned to it. So what I mean by fitting a model is finding coefficients that when combined with proportions, sum to give a result that is as close as possible to the actual data that you got. I found that I got the best fit by adding the quadratic terms, which are a combination of two variables. Each one also has its own coefficient. I know that it might sound somewhat complicated, but it's actually very easy to do using free software like Python. The site Python can do it for you. Next slide, please. Yeah. So what we end up with is an equation that describes the response surface. So this surface here, which can also be represented by a like here. So this equation can describe how the strength or some property, caloric hydration, changes with composition. So from there, you can find out, you can optimize it. Thank you. So that equation is just an example. Shows you what it might look like when I had large numbers. But doing this, I found that I got an excellent fit with an R squared of 0.9776, and was able to find an optimal mixture. Next slide, please. So I think that is probably the fastest method of figuring out a mixed composition, and it also doesn't really need any equipment or dangerous chemicals. So it costs nothing to do. You don't need an X-ray diffraction machine. You don't need to pay for and wait for results from labs. You just need a bit of time, but much less than if you had done it blindly and recommend. So now to quickly sum up the results of my research. The background that I was working with was that it had been found that geochemical both of those factors mean that the steel corrode, that means that the steel reinforced bars inside there corrode much faster. So it wasn't suitable. So it's also known that adding as little as 25% loss on a site actually makes properties much better. So it's even better than ordinary Paul cement. But to sum up, don't try out calcium. It doesn't work. And use next slide, please. I think a future research direction would be to test it in Indonesia using your aggregates that have lots of lime in them because the cracking that you get with Portland cement and lime aggregates doesn't go with your polymer. As I said, the calcium from lime doesn't have any effect. And slide please. Yeah. So question at the end. But if you're working working in stereo or you want to, feel free to add me on WhatsApp, and I can answer the rest of the questions that you have. Thank you.
Thank you, Jack. Very good presentation. So now we come to the question and answer session. So I will share the internet chat box in Zoom or in this room if you have any questions. So in the chat box in the Zoom, we already shared the link for the questions to be filled. Maybe you can share it. And then question, yes, Martin?
Yeah, Dave's gone. Oh, there he is. Yes, Dave, I really enjoyed your presentation actually. The literature review methods that you've used were really good actually. I really enjoyed those, and it's a great way to see how you've done that for future research. I was particularly interested in you showed one diagram where I think you were saying that the fields of research that were disappearing off into the background were probably where future research could be conducted, but in the foreground were key items, key topics that were strong. I just wanted to see if I could better understand the meaning of that slide. Particularly in relation to where you'd mentioned metakaolin and what the implications were for the research findings around the metakaolin. Yeah. Yeah. Go back to this slide. You go back. Oh, is this one here? Yeah, 11. Yeah, 11. Can you pull up 11? Oh, maybe further back before this. After. Was it after? Yes. Yes. How does that one work? And what implications for the medication?
think I better display to Martin first from my computer and then display.
Oh, no, fine.
Okay, no.
What's the implication of
The implication, yeah. So we can select all each one of the circles that may impress you, and then when I click one of them, it will display every connection and every connection to other bubbles from other masters from different colors, from blue, red, yellow, etc.
Yeah.
And those that are not connected, then it will be our potential research gap.
You want to say?
The potential research gap.
Ah, yes. Yes.
So at this moment I click specifically for acid resistance, and acid resistance apparently does not connected to sodium sulfate or phosphoric acid or kaolin constituent component or waste management, and yeah, that might be ours. Yeah.
Thank you, Dr. Day. Yeah, so maybe I would like to read the question here to represent our speakers. Maybe the question says, whoever is researching about aggregate replacement, and Murdoch is researching about cement replacement. Can these two be combined? So whoever aggregate replacement. No, whoever is about the PVC, right? So maybe, okay. For the next question, or maybe, okay. This one is for Dr. Day. Again, how big of an impact would bibliometry contribute towards environmental or geopolitical? This is also your bibliometric analysis.
Thank you very much for the activist student or lecturer that asked me the question. At this moment, maybe not much, but at least we need to do some mapping in order to know what type of problem that we will face in the future. So if we find an enemy that we do not know anything about it, then we will be doomed. Yeah, that's why I perform this kind of analysis in order to know something in details about our enemy, quote and unquote. Yeah, in order to get insights on what we are facing today and in the future. Yeah. Thank you.
Okay, thank you. Are there any questions from? Okay, are there any questions from the students? Okay.
Hi, I actually have a question for you, Jack. On your slides, you talked about a component called slag, and I have no idea what that meant. Could you help me out with that?
Good question. Sure. Sorry. I didn't quite have time to cover it. But slag is short for ground granulated glass kind of slag, a byproduct of steel production from when from its smelted. So currently it is used as a replacement, a partial replacement in Portland cement, or Portland cement. But I think it's got my application as an additive to geothermal. It's not something that we really have in Australia because we don't have steel production, but there is some in Indonesia, as I it does impart some good efforts on yeah, but it's available in much more quantities than flashes. So coming up with some replacements for it, I think it is available, especially when it's not available.
Yeah, so following on from that question about what is the slag, what about all the civil engineers here today? Are any of you in your work with concrete, are any of you using, and I'm glad Dr. Oki is here as well now for this question, are any of you using slag in your additives to concrete and any of the experiments, and you know, what type of results are you getting here in Indonesia?
Well, typically in our curriculum here in Bidang Nusantara, we've never actually, we can't say never, but we rarely touch that area, additives or like slag in general. But we definitely research a few things about it. Actually, just limited to literature studies only. But like in practice, we have not yet tried anything with slag or additives. Probably, I think like there's like a few research on it, but I think it was with epoxy and not with silicone.
Juliana or Oki, or actually you guys, do you know where we can get slag? Can we get slag?
Yes, we usually use additive like
Iya, Pak.
yang paman itu Pak.
Cypack, Pak.
Cypack, like Cypack. That's the high level of cement.
Bisa.
And which
Ada
is
juga.
then important and then can be stick
Dia lagi nanya aditi.
the crack. That's very effective for that. But also for the dam structure.
Bukan. Dia nanya apa sih?
If we want to start a research collaboration and we want to take the research by Jack further to get a new type of geopolymer cement that can be effective in marine environments for chloride systems, and you know, we need to add slag.
Slag.
Because the slag is the waste product from the steel industry. So, is there steel making industry around Jakarta?
Yes.
Banten.
Banten.
In Banten, in Cilegon, west of Java.
Yes, in Cilegon.
Can we visit the next time?
Yes, sure. You can make
Take a bucket
method
and get some slag. Yeah. Next time.
Still slag.
Okay, so
Still slag. Iya, still slag.
yeah, I have actually here in my chat box. So question to this one is to Madeline and Catherine. So you've been to during the activities in your slides. So what do you think? Is Indonesia have done enough to protect its environment? And if not, what other things can be done to protect the environment?
So it's been super interesting traveling around Indonesia, talking to all the environmental experts.
biodiverse country. We really want to protect that, and it's only going to thrive in native forests. So, this isn't really something anyone in the group can control, but it's really important to keep those pockets of biodiversity wherever we can, and not just plant monoculture plantations.
Thank you so much. Maybe due to the time limitation, maybe last question for Martin. So there's a question asking about in Australia, what kind of infrastructure at this moment is using geopolymer concrete the most? Do you know what is the kind of infrastructure?
Yeah, that's a really good question actually. There's no companies in Western Australia yet that are making geopolymer. So this is why we think it's a really good opportunity. And so far we only found one company in Indonesia that we visited today, Data Technology. So, but anyway, the question is about Australia, not Indonesia. And so in Australia, there are 4 companies in the eastern states that already make geopolymer concrete from fly ash and other waste materials. And the biggest one is a company called Wagners. And they're so big, they're now going international. And they make a wide range of products. They even poured a very large concrete runway for, like an airstrip for the airplanes, and then poured the whole runway in geopolymer concrete. But to directly answer the question, which was what is it mostly used for, well, from what I've seen of those 4 companies in Australia that make it, I think the most common application might be concrete pipes. It somehow seems to work well in moulding applications like you need to make concrete pipes. And a really interesting one by one company in Australia called Rockler is they will make sewer pipes out of geopolymer concrete, because the geopolymer has a particular resistance to some of the chemicals that you find in sewage. So that is a really interesting application, and I think one that many companies are interested in. But there's many other products as well.
Thank you so much for the question, for the answer. We come to the end of our seminar. Thank you, Dr. Martin, for the research progress in the collaboration with Product Binus, and Ibu Eri, thank you for making your time during your hectic life with the PhD and working in green, and also Dr. Day.
Sorry, Juliana, there wasn't any questions for Ibu Eri, but I have one question if you don't mind. Because I really enjoyed her presentation, and we went to the Green Hope Eco-Plastic Factory today, and I was just wondering, in all your PVC research, because PVC is such an important material in the construction industry, and we use so much of it for plumbing pipes in Australia. When you build houses and apartments, you need lots and lots and lots of PVC pipes. So I'm just wondering, can a company like Green Hope, can they make a green eco PVC alternative? Is it possible?
Nowadays the PVC option is not commercialized yet. We are still trying to make the extrusion or calendering process for blister packaging. And if you ask to make greener PVC for piping, I don't know if maybe it's some application, right? Because when you have pipe in your installation, it's supposed to be a long life. Usage, no? So yeah, if you put some additive to degrade, it won't less. Yeah.
Can it be greener?
But the idea, we and our team in ITB and Green Hope will we have an idea to make a chemical who can degrade the plastic if the plastic is already in the landfill. So without so it's because every material have its lifetime. We cannot recycling the plastic for more than 4 or 5 times. Yeah. So when it's already in the landfill, we have an idea. We conduct the research on the chemical to develop the chemical who can degrade without UV, because the oxium need UV to degrade the material. It's also something interesting to solve the problem of waste of plastic waste. Yeah. Did I answer your question? Thank you.
Thank you so much, Bu Eni. Yeah. Okay, so we come to the end of our seminar. Thank you so much once again for Dr. Martin, Ibu Erni, Dr. Dave, finding the novelty of the geochemical research collaboration, Madeline and Catherine, for reviewing your activity during Indonesia and environment problems overview in Australia and Indonesia. Jeff, thank you so much for sharing your research results. So, before I hand this to the MC, I would like to invite all the students to take a picture with all the students online. So I would like to invite Bu Erni, Dr. Dave, Martin. We can have a picture here with the students. Please turn your camera on. We have for script, Burinda, please have a group photo also. Pak Hafiz, Ibu Maya, all the students, Farel, who else, Andrew. So Nandi, yeah, all the students, all the participants.
Tuh Ferianto. Next slide ini. Next. Nanti ganti-gantian, capek. Next slide. Yuk.
Okay, all the slides in the Zoom also there.
1, 2,
1, 2, 3. Okay. Thank you so much. Terima kasih. Okay, I hand the session back to Farel.
Gak apa udah. Maafkan, gue ada foto bu.
Thank you, Dr. Yana, and to all the speakers for such inspiring insights. I hope everyone here or everyone at home find this afternoon presentations to be fruitful and very engaging. Before ending today's session, I'd like to remind Venusians present here to fill in the attendance form, and the Venusians at home to stay present until the end of the session. Oh, and before I close today's session, I'd like to invite Dr. Oki to come and hand over the certificates for all the speakers, and I also invite all the speakers to come up here. We'll have like a short documentation session again. And the moderator for today. Group photo shoot.
And Dr. Oki, because Dr. Uriana has been doing so much work all the time planning for this, I brought a special present from Australia for Dr. Uriana. It is Australian honey. Yeah. So thank you, Uriana, for all of the work you've done in hosting this food. And a bit of nature from Australia, from the birds and the bees and the plants.
Thank you so much, everyone, and thank you, Dr. Oki. So, we have reached the end of this seminar. Once again, the entire Civil and Environmental Engineering Technology Seminar Committee would like to extend our greatest gratitude to our honored speakers and Dr. Uriana for your contribution in an integral part of this event. We'd also like to take this opportunity to thank every attendee, whether it's here or on Zoom, for your active participation in this seminar. We hope everyone enjoyed the program. Thank you for your attention. Stay safe, have an amazing rest of the day, and happy holidays.